I'm now going to talk about different ways you can describe the relationship between two variables. If you want to use a tabular representation to investigate the relationship between two variables, you can create a cross-tabulation. Tabular summary of the data for two variables is easy. I've actually shown you an example of this before. Your variables can be categorical or quantitative. If you have categorical variable, then it's easy to create a tabular representation for that. But if you have quantitative data, again, remember, you want to classify it into categories, into classes, so that you can present that data in a tabular form. Now, with graphical displays, sometimes we look at scatter plots and trend lines to investigate the relationship between two quantitative variables. Why do we want to present more than one variable in a table? Again, because we are trying to investigate a relationship between these two. Let me show you an example. What I have here is the quality rating and the prices for 300 restaurants in LA. Notice that my sample size is 300. That's the total number of restaurants I have in my sample. And then the quality rating is actually a categorical variable, and it has three categories: good, very good, and excellent. And then price, which is my other variable, is actually a quantitative variable. But we have classified that quantitative variable into four classes: 10 to 19, 20 to 29, 30 to 39, and 40 to $49. And that's going to present how pricey the meals are at these restaurants. So we want to know whether there's a relationship between quality rating and the prices for these 300 restaurants in our sample. So what does this table really tell us? This says, for example, there are 84 restaurants out of 300 in our sample that are rated good. There are 150 that are rated very good. And there are 66 that are rated excellent. It also tells us that there are 78 restaurants that have a price range of 10 to 19. There are 118 restaurants in the price range of 20 to 29. There are 76 restaurants in the price range of 30 to 39, and 28 restaurants in the range of 40 to 49. What about the numbers inside the table? The 42 here, for example, says that there are 42 restaurants that are rated good and their price range is between 10 to 19. Or the 64 here says that there are 64 restaurants that are rated very good and their price range is between 20 to 29. Or if you look at the 0 here, that just means there is no restaurant that is rated good and is serving food that's very expensive, 40 to 49. Now, how does this tell us whether there is a relationship between these two variables or no? If you look at the figure here, you kind of see that the numbers that are up here are relatively smaller, and then the numbers that are also down here are relatively smaller. So that means there are not that many restaurants that are rated excellent and they serve cheaper food. And there are not that many restaurants that are rated good that serve more expensive food. So maybe there is actually a relationship between these two. And that is, the higher the quality rating is, so as we move from good to very good to excellent, the prices of these restaurants gets higher and higher. So there is a positive relationship between these two variables. The better the rating, the higher the prices. Let's now look at the percentages of this distribution instead of just looking at the frequencies. So we're going to do row percentages first. This is the row percentages for the data that I was just showing you. So I take the number inside the table and then I divide it by the total of the row. So notice all of the row totals right here are 100% because we're dividing by the total of the row. Now, among restaurants that are rated good, 50% serve food between 10 to 19. About 50% actually serve food that's right below 50%, serve food between 20 to 29, and a very small fraction of them serve food that's expensive, above $30. Or you can say among restaurants that are rated excellent, most of them serve food that is expensive, between 30 and 49. And not that many of them serve food that's cheaper, in the price range of 10 to 29. So again, this is telling you, in some sense, there is a positive relationship between quality rating and prices. Let's now look at the column percentages. Now, the gray ones are the row percentages, and the darker ones are the column percentages. Notice that the total of the columns is 100% for all of them, because we're taking each value and dividing by the total of the column. So what do these numbers tell us really? The 53.8, for example, here means among restaurants in the price range of 10 to 19, 53.8% of them are rated good. 43.6% of them are very good, and only 2.6% of them are excellent. Or you can say among those in the price range of 40 to 49, 78% of them are rated excellent, whereas none of them are rated good. So again, this in some sense tells you there is a positive relationship between quality rating and prices. Now let's look at the row and column percentages at the same time. So if we look at that, this is all the data. Again, you're going to investigate the relationship between these variables. So again, you're going to see where the larger numbers fall and where the smaller ones fall. And you can kind of see that we have a smaller numbers right here and over here, kind of. So the higher the quality rating is, the higher is also the prices, and the lower the quality rating is, the lower is the prices. So there's a positive relationship between these two variables. So that's the tabular presentation of the data, or the cross-tabulation, if you want to investigate the relationship between two variables. The other way you can do this is by a scatter diagram or a trend line. So you're going to take one of your variables, put that on the y-axis, and put the other one on the x-axis, and then each dot on your scatter diagram is going to present one observation. So for this observation, we're looking at a price of just below 1 and a quantity sold that's about 70. Or for this other one on the picture, we're looking at a price of about 1.5 and the quantity sold is about 50. Or if you look at this other one here, the price is 2.5 and the quantity is about 60, and so on. And then we try to fit a line to this data. And you can see the fitted line passes through the middle of all of these points on the scatter plot. And because the slope of that line is negative, we call this a negative relationship. Now, this shows a negative relationship between quantity and price. If you've taken an econ course before, what do we call the negative relationship between quantity and price? If you said demand curve, you're right. This is similar to a demand curve. And I leave you to this.